Hi, so we're just going to do some rotation exercises with some AVL trees. So the first one is this one, so please identify where the imbalance occurs and try to fix it. All right, so this is how I look at it. So again, to identify kind of imbalance, we start at the bottom, work our way up the tree, and then we would arrive at the root node and realize, on the left-hand side, the subtree, the height is 0. On the right subtree, the height is 2. So that's where the imbalance occurs. And then the next thing we have to do is to identify the type, where exactly, how do we exactly fix the imbalance, right? And this case is starting at the root that violates the AVL tree invariant. The left subtree is higher, so this is left subtree, and then we go down to the left child, and it's the right child of this left child that is higher. So we're in the case of a left and right, which means we'll have to do a double rotation. And for the double rotation, the first rotation occurs lower in the tree, and that is rotate to the right. And so we basically just take 82 and bring it up to the root of the subtree, and we attach 779 to the right of 82. Keep 800 as the right child of 779, and now we have to kind of take care of the number 486, which used to be the right child of 82, but now we have to attach it as the left child of 779. So that's one rotation, and now we have to do the second rotation higher up in the tree. But the same thing kind of goes, and this one is actually easier because basically 82 is going to become the root. Attach 865 to the right, to the left subtree of 82, and we keep 13 the way it attached to 65 before, and everything here stays the same, and that's our answer. Okay, second tree, and again, identify the balance and imbalance and try to fix it. And here is, if you think about it, again, work your way up from the bottom, and again, the imbalance actually occurs at the root. And to identify the type of imbalance, we go down, we starting from the node, from the root node, we look at, okay, the right subtree is higher, so we go down one level on the right subtree, and then again, the right subtree of 9 is higher. So this is the right situation, and we're doing a single left rotation. And that single left rotation, we are basically bringing up 9 to be the root, and we're attaching 6 to the left of 9. 5 stays the same. The only complication again is where the number 8 goes, because it used to be the left child of 9, but now it becomes the right child of 6. So here is another tree for you to identify the imbalance and try to fix it. Now, before you do that, I just want to point out that if in all the insertion, we strictly follow the AVL tree algorithm to balance it out during each of the insertion, it is actually impossible to get a tree that looks like this. And I'll leave you to think about that a little bit, why. This tree is there just so that we can do some rotation practices. Okay, so let me maybe try to explain a little bit of why it's impossible to have this as an AVL tree, quote unquote AVL tree in the first place. Because we all know insertion, we always insert one of these numbers at the leaf node, right? Now we can assume the new number is 14 here, and if we remove 14 and look at the tree that's left, that's not an AVL tree. we can assume we just inserted 41. We can remove that, but the tree is still not an AVL tree. So as a matter of fact, even if you remove any of the leaf nodes, it's not an AVL tree. So it's just not an AVL tree to start with. But anyway, if we are asked to fix a tree like this, so the imbalance, as it turns out, it occurs at the root. And we can identify the type of imbalance is it's the root's left subtree is higher, so we go down on the left, and then at this node, the right subtree is higher, so we are in a left and right situation. So left right, we do a double rotation. When we start lower in the tree, we rotate to the left first. We bring up 46 and attach 32 to 46 on the left, and take whatever's 41 and attach it now to 32. And then we're done with this step, and then we do the next rotation to the right, higher up in the tree. And that's I believe you get kind of the idea now is basically 46 now becomes the root, and we take 65, attach it to 46, and we take 50 that used to be here, and now but 50 now we put it on the left side of 65, and that's it. That's actually a perfectly balanced tree. So one more exercise. This is a slightly bigger, well, it's maybe one of the biggest tree we'll work on. So try to work on balancing this tree. All right, so here it is one more time that to identify the node that violates the AVL tree invariant, we start at the bottom, and for this one, it's not at the root, it's somewhere, not at the leaf either, somewhere in the middle. So the node 50, the left tree is height 0, right tree is height 2. So the difference is 2, which is more than 1. And the type of violation or the thing that we have to fix is right and left. So that's double rotation. The first thing we do is to, the first rotation we do here is a single right rotation. And then once we do that, and then we do a single left rotation, and then we finally arrived at a tree that looks almost perfectly balanced. Okay, so those are all the examples that I want to show. And now I think it's important that you actually get more exercises with the rotations. That's how you learn and understand and get good and get quick with rotating trees. So here are a couple of suggestions. So the first thing is, in the readings, there are some problems that you can work on. Do note that some trees in the readings, they actually don't start as an AVL tree, and they don't end in the AVL trees even after you do the rotation that was being asked of you to do. However, they're good for practicing rotations. And the second thing is you can actually create more BST on your own, right? And that actually helps you to understand BST in general and AVL tree in particular. So create some trees on your own, identify the imbalances, or and then try to fix them by hand, right? Going through the algorithm, follow the algorithm, and fix them by hand. And then you can, as I mentioned earlier, there's some online visualization tools that are also good to verify your results. So do verify the fixes that you make, and make sure it is correct. And then finally, if you actually manage to create some BST that is kind of fun or challenging, to balance out. Please do share them in the forum. Just take a screenshot like I did with those visualization tools, and maybe challenge your classmates to try to balance those trees out. So, but again, it's just important to get a lot more exercises with this.